Famous theme, always wanted by everyone. It's driving packaging and testing needs. So, Holger, your talk.
Thank you. You can, of course, just put up your questions in German. I will answer them in English. And I'm also fine to have interactive. So we have Martijn here and maybe others who just want to drop in something, that's fine. Unless it gets like too much, then I will postpone. Okay, so I've been involved in many projects, and one of my recent projects this year is a new packaging server. So I'm going to talk a bit about this. So if you look at, this is a graphic from Tarek Ziade. It's the history of Python packaging up until 2010. And you see a lot of things happening, like the start of this tutorial's special interest group mailing list and various features that got built into Python 1.6. Metadata was added, setup tools, which is something that, who's using setup tools here? Okay. The other ones probably just don't know, they also use it. And then there was what Tarek calls the Grand Depression for a couple of years, because not really much happened. And then we had Distribute, which was a fork of setup tools, because the original maintainer of setup tools, which is an extension to distutils, which is packaged with Python, that wasn't really maintained. So problems with newer Python versions and various issues weren't resolved, so there was a fork. And then there were various PEPs following up, trying to improve and formalize basically new packaging metadata, new mechanisms for versioning, to get some kind of structure into version numbers, and so on and so on and so on. And then there was actually almost a new packaging library built into Python itself, which was going to be called packaging. So you could have done import packaging and do various kinds of things that actually implemented the PEPs. But in the last minute, this was pulled out of the Python core. So it didn't become the part. Now we actually have, as a follow-up project, something called distlib. But this is going past 2010. So in the years since then, we still had a lot of developments. In general, the problem with Python packaging maybe can be summed up that we are still kind of catching up with what CPAN has done. Who knows CPAN? Still a few people, right? The Comprehensive Perl Archiving Network, which is for which has something like 500 mirrors and allows to has a certain standard for testing packages. So you don't not only upload things, but actually there's a standard for running tests. And they get distributed. They had separation of development versions of packages and release versions. And this is like 10 years ago, right? They had this all. We are still trying to catch up in some ways. So that's a bit the situation, but let's not get too sad about that. Because the problem, I think, here is that it just takes a lot of time to evolve all this ecology. And especially if you consider we have 35,000 packages on the Python package index, and it's and we cannot just like introduce a completely new scheme. Like now we do everything through JSON. We throw away all the installation tools and everything. This would basically lose us 35,000 packages that we can't then use, but everybody has to migrate. That's kind of a difficult way to improve something, always. And so I think we need to look at things in a more backward compatible manner. What is currently happening is that there's many improvements going on, both in core Python. So, for example, pip is going to become part of Python 3.4. It's going to be bundled with Python. That's just, right now it's just being prepared, and the November release is actually going to include it. Now, not too many people are using Python 3, but still, it's significant. There's also going to be a bootstrapping script for pip that works for all the old Python versions, and that's going to be offered from the python.org website prominently directly with the interpreter. That's at least a good step forward. There's many new PEPs actually currently being worked on, and it's somewhat confusing to find how should I do things now. Like if I start a new project now, what should I do? What should I use? Moreover, it's one of the problems is that many things can go, when you do packaging, many things can go wrong, so that you end up with a package on the package index that is not really nice to, that doesn't really install even, or has some files missing, or has too many files in there. It's like a megabyte download, and should only be like 100K download because there's some residual files. And then, if you're working in a company or your own organization, then you have the issue of having something like your private package index server. The current infrastructure that the public Python package index deploys is not really something that you would want to run in your company for various reasons. So there have been many pypi server implementations. I did a survey, I think, when I started this project, and we had something like 20 pypi server implementations, of which 8 appeared to be somewhat maintained. And so we went through all the features and looked what is useful there. But really very few are maintained and evolving still. There have been kind of like one-shot projects, and they did something and then they're just there. Okay, I mentioned the tools and PEPs already. Very important is setup tools is now kind of like the grand base. The fork distribute is now merged back to setup tools. The original guy who did this, he agreed to have this merged. So now we have a maintainer who's very responsive to issues. I think he has done something like 8 setup tools releases this year. So it's really moving forward. We have pip majorly being worked on. Distlib, which is the follow-up from packaging that should have been included with Python, but is not going to be. And distil is also an installer that is based on distlib. It's kind of an interesting installer because it's only based on JSON-specified metadata. Then we have, as pypi mirroring and server implementations, Devpi server, which I'm going to talk about. Bandersnatch from Christian Theuner, he's also here at the conference, for mirroring the public Python packages. PEP 438 is something I wrote with Karl Meyer earlier this year, and it's the main reason why the current installs in pypi are kind of fast. There's 2 reasons pypi has gotten like a 10 times or more speed up in the last year. One reason is this PEP, because it basically allows to declare projects to be pypi hosted only. So you say basically in my project I'm always going to upload the packages. I'm not going to offer my own website which serves the release files, because that was kind of like the previous standard. So when pip 1 year ago wanted to install something, it needed to go to the package index. Then it saw all the third-party home pages, download pages, whatnot. And then on the client side, you would need to crawl all of these packages. And that takes time and is unreliable, because one of these pages might not be reachable. So PEP 438 fixes this. So I think nowadays something like 80 or 90% are really pypi hosted, and pip doesn't need to do any kind of crawling anymore. It just asks once at pypi and it knows exactly what's there and doesn't need to do anything more. The other speed up was because the infrastructure moved to CDN, a content delivery network, which had a lot of problems, but now I think it works kind of nice. One of the very interesting developments is PEP 426, which is the so-called metadata 2.0. It's still in progress. Several revisions in the last month, and very good people trying to move this forward. It's the metadata standard that has a JSON representation and is also the one that is used by the new wheel format, which is the next PEP, PEP 427. It's the wheel binary package format. pip can directly install those. And pypi also supports uploading those now, and so on and so on. So that's all going to be, that's likely going to be like the new standard how you install packages, but there's an incremental way how you can evolve. You don't need to suddenly serve wheels everywhere. You can just start with one project and then another and so on.
So how is this different?
Sorry?
How is this better than X?
It's much more thought through than X. So the question was, how is this better than X? X is the format that was used by setup tools, introduced. It's a binary format that allows, for example, to not serve even the source code, just the PIC files. So it's Python version specific, and it's also platform specific. And wheel is basically egg, but much cleaned up and discussed in a PEP and connected to all the other metadata PEPs and so on. And I'm also closely collaborating with Donald Stuft, who has done, he's like implemented parts of PEP 438. He's also a pypi administrator, and he's working on a new infrastructure called Warehouse, which is the next generation, or which he wants to become the next generation Python packaging server that is going to serve pypi.python.org. But that's kind of like, there's already a web page that you could use, but it's very much work in progress currently. It's really more for developers who are interested in the stuff, how it's implemented. Okay, now in general, my approach here is if you look around, there's lots of people actually who have discovered in the last 10 years, oh, this is all really annoying, the whole packaging thing in Python, and I need to do something on my own, which is much better, and everybody should use that. And that's always a difficult proposition to say, like, okay, everybody has to change first, but then it will be great. I think that's kind of a general principle that does not only apply to pypi. Also, if you introduce something in your organization, like a new concept or so, don't try to demand first everybody needs to change, and then my idea will be great. You know, it's always a good idea to try to find some kind of incremental way how you can improve things, because the risk is much lower that you're not just introducing yet another way to do something, and the other ways still need to be done because they have some special features that cannot be replicated. Okay, so Devpi takes what I call a wrapping approach. It kind of like invokes all of the current modern tools and works with them, and but wraps them. That's kind of like the client-side tool chain, and then there's server-side tool chain. These two parts are kind of independent. So you can deploy a Devpi server, which is a pypi compatible server, and you can use your standard setup packaging steps. You can use standard pip easy install using Devpi as an index server. But there are some reasons why it might be preferable in some situations, or in many situations, that you also use the client-side tools, which I'm going to talk about. Okay, so why a new index server? Told already, 20 pypi servers we did investigate. So at least we have some defense in terms of not just doing something without having researched first. One problem I saw with almost any pypi server, they didn't really have a tested code base. So if I just take a pypi server and want to extend it to build new functionality, and there are no tests, it's going to be really hard. And from my personal, I mean, I'm very involved in testing since 10 years or so. Personally, when I do a project, or I'm involved in a project, does testing, it's 50% of the effort. It's effort well spent. But it's really a huge part of the effort of doing kind of like a mid or long-term project. So if something doesn't have that, it's kind of like missing a very important half for me, especially the one where I get to modify things and play with them. So that's one problem. The other one is that it's not really possible to have something like an off-site installation scenario. So you basically kind of work with the server and you pull in some packages, and then you can work completely offline. At least it's not convenient with most of the pypi servers. Most of them actually, when they get to offer public pypi packages, they just do a redirect to the pypi packaging server, the public one on the internet, and that means you need to be online at that point. They don't really offer any kind of support for staging. So you have development packages in your team and you want to push them somewhere else. So they become a release candidate maybe and then actually get released, either publicly or just to your company or to another company. And most servers didn't support that. Also, coming from testing, I think it's very important to put the actual distribution file, the release file, to put this in the center of things. So that's the thing I'm going to install, and that's the thing I want to run my tests against. So I actually know that this package I'm going to push somewhere else is really passing the tests and is really working. That's something, and that means that I want to have my test results attached to the release file. So I really know if I look at this release file, I can see, okay, all of these test scenarios actually passed. Now I can move it on. Another thing that almost no pypi server has is data migration. So basically, if there is a new release, I mean, either there is no release, so there's no new release, so you don't get any new features. But if you get new features, then there's a problem with data migration. So you basically start afresh. Yes?
To when you say recording test results from CPAN, I know this protocol called TAP, test anything protocol. Not sure if you're familiar with that. Do you have something similar in mind there?
Yes.
Or?
Yes.
And
not only in mind, but in code.
I would be extremely interested in how that looks like.
Okay, I can show you the JSON.
Awesome, thanks.
Okay, so the server itself, to touch the first point, has 300 tests only for the server part. And it's also fully tested to work over all of the 35,000 pypi packages and work with them. And there are some very, very weird projects. You wouldn't believe it, but I can tell you over dinner. And it's also, I mean, I spent a lot of effort actually trying to get proper testing in there. It's not actually that easy if you consider that it's lots of network connections and crawling involved and so on. But it's very important to actually be able to move on. So, well, how does it work like? Index organization. Devpi server has multiple indexes, not only one. It has multiple users, not only one. So basically what you have is you have some kind of root URL, and then you have multiple users, and each user can have one or more indexes. You don't need to use this at the start. You just have one index and one user maybe on your laptop. But as teams evolve or something, or as you are moving towards an organizational company deployment, you might want to actually have multiple users. Each index can define who is able to upload. It's currently the only ACL. Everybody can use indexes, so the packages that are on them. So if you have a deployment in your company, then everybody can use any index, but only select people can upload. Then caching. A big part of the implementation, I would say 20-30% of the implementation effort was spent on effectively, efficiently, and intelligently caching pypi. So what Devpi server, in contrast to Bandersnatch, that does a mirror of all the release files of pypi, which is over 40 gigabytes. Devpi only caches the files that you actually use. So when you have like 80 projects that you access directly or indirectly through dependencies, then all of this metadata will be cached in the server. And if you access then several release files for performing installs on your production machines or on your local laptop, then those will be cached. So once they are cached, you can after that do an offline install. You don't need any network connection anymore. What is very important here is that this fully integrates with the recent changelog API, which is something that pypi offers, where I can ask, okay, what changed since that revision? There's an internal revisioning scheme in pypi now. So what changed? And then I know these 9 projects changed, and of them I'm only using 1. So I'm only updating this one. The other one was never requested, so I don't need to like cache it, to refresh invalidate the cache. So it's only invalidating the cache for the entries where something has changed, and that's very efficient. So the network bandwidth that is used from Devpi server to pypi is minimal. Basically, it's a very efficient network protocol there. Also very important, even third-party pages are, yes?
One question, can you also do...
Sorry.
Suppose you have a development network that is hidden behind lots of firewalls where you can't access the internet. Can you do a Devpi installation on some machine that is connected and then install all the packages that you need and then move the installation?
Yes.
Okay.
It's totally possible. We talk about this when I talk about data migration. You will see how this is very easily possible. Okay, caching of third-party tools. As I mentioned before, there are still something like 10–15% of the packages on pypi. They require that third-party pages are crawled to detect release files. And this is something that Devpi server does on the server side, so the clients don't have to. So when you do a pip install from a Devpi server index, everything will be served through the pypi server, even the links that go to GitHub. So all the even development snapshots and everything like this, they are actually routed, proxied through the Devpi server. So basically, when GitHub can't be reached, happens from time to time, then you can still use a Devpi server. Okay, so that was caching. Then a very important property of Devpi server is what I call index inheritance. Root pypi is the root user is kind of arbitrary, but the pypi is really the cache from the public pypi python org. So it contains all of those packages. And here, my own user, dev index, inherits from that index. And that means that all the packages that are visible on root pypi and installable, they are also directly installable on my user dev index. They're just available. They are virtually available because Devpi server internally basically manages this inheritance. But when you go to the index, you basically can get a full list of things, and you are going to see your own packages and the packages from pypi that you can install. That means that you can either have newer versions, like development versions, on your user dev index that also exist on pypi, but you can also have packages there that only exist in your private index. So you basically your company private packages that you never upload to pypi. Okay, so this means that this inheritance thing makes it very, very seamless to have your own package, yet depend on public packages, but have all this served through one company instance. Recording of test results, I talked about. What it means is if you're using Tox, kind of like a front end for running tests in Python, you can use PyTest, Nose, unit test, whatever. Since release 1.6, it supports creating a JSON file that is not yet in a PEP or anything like that, but it's kind of, because it's more work in progress currently, but it captures a lot of information about where tests are run, on which platform, which Python interpreters, which dependencies are installed, what are the exact test results, did the test setup succeed or fail? Because a failing setup does not necessarily mean that your tests break. Just means that somehow your test environment couldn't get set up. So these are all things that are distinguished in the result file. And there is, if you upload something to an index, you can trigger Jenkins to automatically take this archive and use it to pipe it through some Jenkins hierarchy. And from there, you can actually post back test results to the Devpi server. I talk about this in a second. But you can also attach test results just from your laptop. So if you run tests on your laptop, there's a command that will get the package, unpack it, run tox, create the result file, turn it back, and then others can see which tests have already run on which platforms against this release file. And this is information that you can query in JSON, so you can easily write scripts that do something automatically based on this information. Data migration, also a feature of Devpi server. That's introduced in 1.1 and improved in the upcoming 1.2. Basically, Devpi server has an export option where you specify directory and has an import option where you specify directory. And it means that if you have a Devpi 1.1 installation and you do an export, then you can use Devpi 1.2 to import that. It's kind of there to neutralize all the differences between the versions. And upgrade state is an upcoming feature in 1.2 that actually does this almost automatic. No, it does this automatically. So it detects in what format is the current server data and test results and everything. It installs in a separate virtual env the fitting version, does the export, and then imports it into the current version. So at the end of the operation, you have basically upgraded, and you don't have any data migration problems using the next Devpi releases. Does that answer the question? About? Yes. Because, sorry, I didn't say it explicitly here, but it means that you can have an internet-connected machine, do all your stuff, your installations, then everything, oh, it's not actually quite true, now that I think about it. Because one thing that the export doesn't do currently, but you can file a feature request, is it doesn't actually, it doesn't put all the pypi cache files there. It only cares about all the privately uploaded files. So it recreates the pypi cache. So in that sense, the export is not going to be sufficient to be imported in an internet disconnected instance. It's not, I don't think it's a huge thing to try to improve this, and I'm open to pull requests. Okay, yes?
Devpi seems like a perfect fit for like a continuous deployment setup. How would you? I mean, the idea of continuous deployment is basically you choose a set of good versions if you have multiple packages, and then click a button and then you release, right? And before that you test and everything. How would you manage those multiple packages, and how would you like do the certain stages? Like, would you do egg releases for every commit, for instance, and then just choose them? And
let's talk a bit later about this, because I show some concrete workflows, and then we can take it from there. Compatibility, when you use setup.py with or without setup tools, sdist upload, you can use an index URL from Devpi and it will work. You can use the upload docs, so Devpi server also manages documentation, Swing-based documentation. You can use pip, of course, and easy install to use that index. So for that, there are no extra client-side tools available. You can just install Devpi server and have an Nginx front end that has a nice URL, SSL, whatever, and then just use that. But I think in most cases, unless you're just using it as like, have only 2 indexes and you want to use it in a very simple way or so, then usually you want to use the client-side tools because they help you with managing user and index configuration, inheritance between the indexes, to manage authentication, and they have some support for better uploads of files and test results, and also some help for staging between indexes. We talk about these client-side tools. They're not strictly necessary, but because you could also just go to the JSON API or just use the compatible entry points. But they make a lot of sense, I think, to consider. So for configuration, there is one important command that is called Devpi use. It's a subcommand. It basically sets the current index I want to use. Now I'm going to work on my personal development index. And if I upload something, it's going to go there. If I test something, it's going to try to get packages from there, and so on. Index is for creating and modifying settings of an index, like the basis. Users is for creating users and passwords. And getJSON allows you to, you could also use curl if you like, but getJSON basically gives you a JSON view of the server data structures. So you just go to the root index and you see, okay, which kind of users do I have? You go to the users, you see which kind of indexes I have. You go to the index, you see which kind of projects are there. You go to the projects, you see which kind of versions are there. Sometimes the replies actually span multiple levels deep, so you don't have to re-get things like on a per project basis or something like this, but per version basis. But in general, it's a useful interface if you want to find out about writing some scripts that actually take this information and do some automatic steps based on that. The workflow for the actual development development commands is still you have basically your use index. Then there's devpi install. It's a thin wrapper around pip. Upload. That's a bit more elaborate actually what it does. I get to that. It's basically builds and uploads a package. Test is the one that gets a package and runs the tests and attaches back the test results to the release file. And push is the one for staging. Implemented as an HTTP verb. So basically I can go to the one index and say, take this release and all of the documentation and test results and so on, and move it from my development to my release index. So release workflow. I say, first, use this index. Then I go to some project directory that contains setup.py. I do devpi upload. And then from multiple different machines, and I can automatically trigger that through Jenkins or just have my own mechanism for doing that, I can then just say devpi test this package from that index. And then it will grab that package, run the tests, attach back the test results from multiple machines. Right? And then you can get, I show this interactively in a second, you can see what are the test results on this release file. Eventually, when you're happy with your package, you can push it from one index to another or release it to pypi. So you can say, this is now my new open source release. It's nicely tested. Some people I know in my community have already tested it. It runs on their machines. They're happy, push. And what the certainty that you get here is that the exact binary bit-for-bit archive that was used in all of the tests and used by people for trying out your release, exactly this will to be released. So there's no going back to some git check out and then doing the final packaging step, because then you don't really know anymore if what you're packaging is really the thing that works. Right? That's the typical workflow, and one of the criticisms I have about Jenkins. They work based on checkouts, and at the very end, you do the uploading, but that can go wrong. Because if somebody added some files that are not in the manifest file that defines which files are part of the package, then your tests will all be fine because they are based on the git checkout, but your upload will be broken. And of course you can say, oh, but you have to be careful, you have to write extra scripts and so on and so on. But the golden rule here is make the thing that's the most important thing, which is the actual archive, put this into the center of the pipeline. This is actually moving through the pipes and then getting released. Yes?
But how do you handle version numbers in this scheme? I mean, probably the package testing is 0.1.0/dev/ something like that.
Yes.
And I want to release 0.1.0.
Yes. That's something that Devpi server solves through a concept called volatile indexes. Volatile. Also vorübergehend. I show it in a second what that means. So if you just have, does this still hold, although I'm packing the questions in between?
No, you can have them longer.
Okay, yes. So the per laptop caching, this is something that you can just do in your laptop. You don't need to have a company deployment for that. You just install Devpi, which basically drags in Devpi server and Devpi client. There's a minimal management of a background server, and you can if you just start Devpi server, it's going to start up in foreground mode with -- start. It goes in the background, and then you can use -- stop or status and so on. And once you have that running, you can basically configure this URL, the root pypi one, and then you have your pypi cache on your laptop. So the next time then you use that while you have some internet connection. The next time you're on the train, you can just use that index to create virtual envs and install things and just work offline, unless you hit some package that you haven't seen yet. So that's a very simple use case and it works directly. It's really these steps. There's no configuration files, it's zero configuration, just get going. Company deployment, similar. You basically, of course, you want to integrate this in your init scripts somehow, but otherwise you install Devpi server, you run it with a certain host port setting, and then you probably use some kind of Nginx or Apache front end for SSL, and then you basically, from multiple client sites, you just need Devpi client and use the index and get going. So it's a very simple deployment story. The staging, and that goes back to one of the questions, is we have root pypi, and normally, I mean, there are some situations where people don't do this, but normally that's the one that you inherit from everywhere. In this case, in this company, we have a release stage. That's the one that contains all the packages that have been released company-wide and are kind of stable. And then we have teams, team 1 and team 2 here. They each have a development index where multiple users can upload to. And basically, from team 1, somebody might upload to team 1 dev and test a bit or tell others to test. And once that's fine or reviewed, then you push it to the company 1 release index, and everything is fine. While you do that, like in team 1 dev, in that index, all pypi packages will be available as well, because it inherits from company 1 release, which itself inherits from root pypi, so everything that is contained there is visible there as well. So the command wrapping, I talked about the wrapping approach. Devpi upload uses setup.py only for building. At least that's true in 1.2 release. It only uses setup.py for building, for wheels, or for sdists, or even for X. That's your choice. And then it uses requests-based, HTTP-based uploads to the Devpi server index. Devpi test also just goes to the server and invokes tox, basically, in the end. And Devpi install runs pip. So you see, if you go to the files in the repository, how they are implemented, they're usually implemented in something like 100 lines or 120 lines of code. So very small, because they're really just wrappers that take care for all the configuration that you need to do to access the correct index, authentication, and so on. Clean builds. If you do an upload, that's something I always hated when I didn't have that. And I know there's extensions that also help you with that. But Devpi also on upload, what it does is in 1.2, if you have a Git or Mercurial controlled project, it first exports all the version files, no matter if they're currently modified or not. It exports all of these files into a fresh temporary directory and then performs the build there. That also makes sure that a build really has all the files that are needed for building included in the VCS. Because otherwise there might be some files that are only on one developer's machine and he happens to be the one who does the packaging step and it works. The next person tries to do it and it doesn't work because some file is missing. Then the build takes place there. Multiple different formats you can also do, of course. At the same time, you can upload one format or multiple formats, however you like. And you can also use the setup tools Swings integration, which means that you can, if you have a Swings-based project, that your documentation is built and also sent to the Devpi server and then made available there. You see this in a second. Volatile indexes. That was the question you had. The version numbering problem. Version numbering is something where you can read a lot about in the internet and also in Python PEPs and so on. This is a very pragmatic approach. When I do an open source release, and it's probably also true for company releases, I want to say, okay, this is going to be PyTest 243, right? And this is going to be it. Now, if I say that I want to have the exact file, including the file name, everything unmodified, and have that be the basis of tests, then what do I do if tests go wrong? I mean, I package that, and then on Windows, on Python 2.6 or something breaks. Now, I cannot just increment the version number because I really want to have the official 2.4.3 release on pypi. So I cannot just change that. So in that case, I do this on a volatile index. So my development indexes, or development indexes in general, often make some sense to be done in volatile mode. And it means that you can overwrite release files. So I can re-upload this multiple times. But the test tracking that takes place is based on the content hash. It's not based on the version number. So Devpi knows exactly how the tests relate to the release files. It's not just using the name and the version or something like this. And that means when I look at the status of the release file, I really see the test and I really know it's exactly that release file that was tested. When I upload a new one, then all of these results will be forgotten because I'm basically restarting with the same archive file. In a release index in your company, and of course on pypi because you can't do that there, you don't want to have volatile indexes. Once you get this out and it's used by third parties, you don't want to overwrite the same version. That's going to be awful in terms of collaboration. So then you don't use a volatile index, so your company release index shouldn't be a volatile index. There you have to go through, if you for some reason, despite all these safeguards, have something that is broken, then you need to increment the version number there. That's bad luck then. Then you should improve your prior steps to avoid this situation. Okay, so the upcoming 1.2 release, what's the news there? If you look at the webpage, devpi.net, you see that when you use an index for installation, you couldn't just use the URL that I have underlined here, but you would need to append a plus simple. That's the simple pages from pypi. Suffix, and that's often has confused people, why you need to add that. I'm not going to tell you why this has been done so, but in 1.2 we found a way basically to avoid this. So you can just use this index directly without any simple suffix. So if you go there, basically then you see, for example, my personal development index contains all of the stuff here. The web interface is very rough, but you see that, for example, I'm working on an ExecNet release and Devpi client releases, and they still have a dev tag. They're not supposed to be like the release candidates, but it's closing up. And I can use this URL basically directly for pip or for easy install in 1.2. Then 1.1 still used distutils itself to perform the upload. And distutils upload protocols were created in Python 2.1 or something. And they don't support SSL in Python 2.6, and you need to install several things to actually make it work at all, and so on. This is all solved in 1.2 because the uploading part of documentation, tests, and so on is done by Devpi itself. It doesn't use distutils for that, which also gives you much better error reporting if something goes wrong. It tells you exactly, for example, oh, you're trying to upload something that already exists in a non-volatile index, so you can't do that, and so on. Also, what I find important, because some companies are starting to use that more elaboratively, is the documentation. Because everybody is rightfully using Read the Docs, the website, to build docs. When you do this on the per company side, you cannot just, it's not so easy to actually to use it. I mean, you cannot use it there privately for your private package. So it's still nice to be able to have documentation on your private packages, but the upload protocol of documentation in pypi, for some strange reason, does not transfer the version number. So it always says, oh, this is the documentation for this project, but it's without version number. So as Devpi server, I'm standing there and see, oh, this is documentation. Now what Devpi does is, if that happens, it assumes, okay, you probably mean the latest version, so I'm just going to look up what is the latest version and attach it to that. But when you use Devpi 1.2 and the upload protocol, it's going to be precise, because the client is going to inform the server what version this belongs to. So you can even, if you have like multiple versions or branch versions or something, then you can even, it's going to be precise there, in sense of tying the documentation to the version. Then there's a change that you shouldn't notice usually from the tools, but if you look at in a browser at the URLs that are generated, you'll see that Devpi moved to have an immutable object URL space. And that means that when you have release files, either from pypi or your own release files, in the URL there will be somewhere in there an MD5, which is basically the content hash of that file. So this can then be statically served from Nginx. So basically you have a pattern match, and you say all of these static files I just serve directly because they cannot change. They're immutable. Once Devpi server has basically put them there, and they are linked from some index, then they can just be statically served. If you compare that to the current pypi situation, you don't have that. If you go, for example, to Django 1.5, then the release file will be in packages source something, Django -1.5. But it happens for about 3 to 5% of the projects that these release files, because there's a trick how you can do it, are replaced. So you're not getting always the same file, you know? So that's something that Devpi actually solves in because it always generates a unique URL for that, and that can be served by Nginx, so it's always completely safe. There's no suddenly it's a different version or suddenly it's a different file. There's no need to do any dynamic checks there. Also, 1.2 has full wheel support for upload and installation, so the pypi server also sorts them, and it supports Git. Previously, it only did HG, Mercurial clean builds, exporting them to a temp dir. Now it also does Git. Yes, that's roughly it. I mean, there's some more things, but you see that in the changelog. Future work. There's always a lot of streamlining that is going on the client side based on people's feedback and pull requests and so on. What is not so nice currently is that we just discover this as some people are trying to have create a systematic view of the 50 or so PyTest plugins and have them tested and query this JSON API. And it's not exactly nice currently. You have to do a lot of requests actually to get at the all the relevant information. So that's going to improve. One thing that is still a task that I have from one of the from the main contract I had to develop this service is replication. That's mostly interesting for like that company and probably other companies that are a bit larger, where you actually have multiple mirrors. So they want to have something in China and in Poland and Germany and US. And then all of those are real-time synchronized. So when you upload something to one, it's going to be real-time synchronized to all of the other instances. And if one instance basically goes away, another part can at least directly be used for read-only operations. It's probably not going to support re-election of a master, but it's going to support at least continuous operation even if one server fails. Then the web interface, you saw it already, it's very rough. I hope to also get some funds and time to improve that. And several people wanted to have, because of the hierarchies and companies, I don't know, people like to have, like to exclude people from certain activities. They shouldn't see that it's like our secret project or something, I don't know. They want to have read access, ACLs. Currently, all indexes are read accessible, but not write accessible. This you can control, but not read. And read is something, now it's actually easier to do for several reasons than it was in the 1.1 series, so that could get implemented in a future release. Okay, so it's MIT licensed. It's the first release was, I think, in February 2013, has 9 releases since then, and we are now kind of confident that due to the data migration features that it can actually also evolve nicely. Because without data migration, every time you do a new release, people are going to say, and now? I mean, how do I, migrate this? And it's of course effort to try to keep this kind of like, this. I mean, if you have any kind of web service or so and you need to migrate, data migration is always a big point. Okay. That's it, yes.
2 questions. Okay, there were already some during the talk.
So one use case I have during development is that I sometimes, and I'm just not sure whether you cover that or need to cover that, is that I have 2 projects and one depends on the other. And I make a change in the dependent on the project that the dependency is on, and I want to run the test.
I know exactly what
yes,
you're going
on
to
the outer one, and I want to develop both at the same time for a little bit.
Yes.
How would you cover that?
Oh, that particular bit is very easy. So, for example, oops, wait a second. Well, I just say it. This is so short in a second. So the question is, if I have one project and it depends on another, and both are evolving. That's exactly the situation where these indexes are perfect for. Because either you just use the development index because you know what's in there, or you just make a new index. It's very cheap. Devpi index -c for create name, and you have a new index. Very simple. And then you upload the one version, the one project, and then you upload the other project, and then when you install from that index, they're going to see each other. Because they're just in the same index. I do this all the time because I have all kind of interdependent tools, and that works nicely. I was actually, I thought that, there's one more goal I have, and I hope to get this implemented not too far in the future. And that's something that's, I think, a real big step. And that is dependency tracking. So when you have a package A, and it depends on package B, and then somebody wants to release a new package B, which happens in the open source world all the time, then there's no nice way to say, okay, when I have this new package, how would all the dependent packages deal with that? Like if I run the tests of those dependent packages, would they also continue to pass? They passed on the prior version. I am going to put out a new one. Do they pass? And that should be, I think, in the end, an automatic operation. So I basically say, I upload a new PyTest thing. That's one of the use cases I have. And there's like 50 plugins, and at least 15 or so of them have a tox INI and have tests actually. So I would very much like to be able to say, okay, this is my release candidate, and now system, go busy all my slaves, and then tell me at the end which of the plugins broke, and show me the tracebacks.
Okay, we have to finish.
I have to finish, yes, okay.
Okay.
So that's basically one of the features I really would like to build soon, also personally.
Okay, thank you very much.
Thank you.
As you maybe